Welcome to subtopic 8.3, strong and weak acids and bases. So what does it mean to say that an acid or a base is strong? Let's consider a prototypical strong acid, hydrochloric acid. If we put hydrochloric acid in water, it dissociates into a proton and a chloride ion. Because it dissociates completely, we say it's a strong acid. What about sodium hydroxide? If we put sodium hydroxide in water, it also dissociates completely, so we call sodium hydroxide a strong base. If we put ammonia in water, it dissociates only a little bit. Therefore, we say that ammonia is a weak base. There are only a few strong acids and strong bases. For IB chemistry, you specifically need to remember hydrochloric, nitric, and sulfuric acids. You should also be familiar with hydroiodic, hydrobromic, perchloric, and chloric acids, as most chemists also consider those to be strong acids. As for strong bases, all the group 1 and group 2 hydroxides are considered to be strong, though IB chemistry syllabus only specifically mentions the group 1 hydroxides and barium hydroxide. If it isn't on the short list of strong acids or strong bases that you just learned, then you should consider an acid or base to be weak. That said, we still need to know a few examples for the IB. Acetic or ethanoic acid is considered to be a weak acid, as are almost all other organic acids. Carbonic and phosphoric acid are other examples of weak acids. We've already learned that ammonia is a weak base, and so is ethylamine, which is an organic base that has an amine group. In fact, all bases that include an amine group are considered to be weak bases. There are three ways to distinguish strong and weak acids and bases: electrical conductivity, reaction rate, and pH. We've already learned in topic 4 that anything that dissociates into ions in water will conduct electricity. Well, acids and bases by definition do dissociate in water. If they conduct electricity very well, then that's a sign that it's a strong acid or base. If they conduct electricity only mildly, then it's a weak acid or base. Strong acids and strong bases not only dissociate more, i.e. push their equilibrium far to the right, they also react faster than a weak acid or a weak base. Finally, the pH scale can of course tell us if something is a strong or weak acid. If we put a strong acid in water, we'll measure a low pH value closer to the 0 side. If we put a strong base in water, we'll measure a high pH value closer to 14. Weak acids and weak bases will measure out closer to the middle. That's it. Thank you for watching.